In question 6 we have a diagram of a stationary wave. In A part 1 we need to describe the motion of point x. Well, point x will oscillate up and down about the equilibrium position. In part 2 we need to state the phase relationship between x and y. Well, x and y are in antiphase, as one goes up the other goes down. And between x and z, well, x and z are in phase, they go up and down together. In B, we're given the frequency of the overtone at 780 Hz. In part 1 we need to show that the speed of the wave on the string is about 125 meters per second. Well, speed is frequency times wavelength. The frequency is 780 Hz. In the diagram we have two complete waves at 320 millimeters or 0.320 meters, so the wavelength is half of this. This gives a speed of 124.8 meters per second, which is around 125 meters per second. In part 2 we need to find the time taken for the string at point Z to move from maximum back to 0. Well, this is 1/4 of a cycle, and the time period over 4 is equal to 1 over 4 times the frequency, as time period is 1 over frequency. Putting in the values, this comes out at 3.2 times 10 to the minus 4 seconds. In C, the string is now shortened to 240 millimeters. In part 1 we need to name the point on the wave midway between C and B. Well, this is an antinode. In part 2 we need to calculate the wavelength of this stationary wave. Well, from node to node is half a wavelength, so the wavelength is 2 times 0.240 meters at 0.480 meters. In part 3 we're asked for the frequency of the fundamental mode. The speed is still 125 meters per second. Well, frequency is speed over wavelength, and this comes out at 260 Hz.